Okay, welcome back to this another video of ARD section, and today we are going to read dryland agriculture, and let us see what are the topics. Dryland agriculture, global status of dryland agriculture, significance, scope, major constraints, drought, contingency planning, alternate land use, suitable trees by soil and rainfall, important institutes related to dryland agriculture. Okay, then we move on to dry farming. Dry farming is a cultivation of crops in regions with annual rainfall less than 750 millimeters. And crop farming, okay, these are arid regions with growing season less than 75 days. Then we have dry land farming, is cultivation of crops in regions with annual rainfall more than 750 and growing season is between 75 days and 120 days. Rainfed is annual rainfall more than 1001 millimeters. Let us see this table. Rainfall for dry land farming is 7 less than 750. For dry land farming it is more than 750. For rain-fed farming it is more than 1150 millimeters. For dry farming it is dry spells occur. Crop failures most common, least frequent. Okay, growing period 75 days, 75 to 120, 1 to 120 days. Okay. Then rainfall for dry land farming versus rain-fed farming. It is less than 100, 800. This is more than 800. Moisture availability to the crop shortage enough. Growing season less than 200, more than 200. Growing regions arid and semi-arid. Cropping system single or intercropping, and here it is double cropping. Constraints wind and water erosion, and here water erosion is the major constraint because of overflooding due to excess water. Then we have other definitions. Hargreaves defined dry farming as agriculture without irrigation in regions of scanty precipitation. ICAR, while establishing the dry land centers in different agroclimatic zones in 1970, used the simple formula of Thorne-Waite 1955 for estimating the moisture deficit index. Moisture deficit index 100, and accordingly climate has been divided into three types: subhumid, semi-arid, arid. Steiner-Elt, okay, FAO classification. Let us see this. This classification is based on growing period concept of FAO. Areas having a growing period between 1 to 74 days are classified as arid, while those growing between 75 to 120 are considered semi-arid. This is good one, no? Arid, semi-arid. Growing period is the number of days during a year when precipitation exceeds half the potential evapotranspiration plus a period to use an assumed 100 millimeters of water from excess precipitation less stored in the soil profile. Okay. Characteristics of dry land: have poor and suitable crop production conditions, only a limited number of crops. Crop intensity is also low. Most crops and varieties grown in dry lands are not efficient in using moisture. Many of these crops are long duration, photosensitive, and have low harvest index and poor response to fertilizers. These problems become worse due to high evaporation and lower water holding capacity. Deforestation, overgrazing, cultivation on slopes increase runoff, reduce water recharge in the soil. This leads to soil deterioration, nutrient loss, lower upland crop yield. Therefore, dry lands need better resource management. Then we have global status of dry land agriculture. Dry land agriculture is the main livelihood source for more than 800 million people. These people depend on traditional and fragile farming systems. Low and uncertain rainfall affect about 40% of the world's land surface, and 60% of this area is in developing countries. In most dry land regions, local rainfall is the only water source of crop production. Because rainfall is low, irregular and unevenly distributed, long dry spells are common. In the areas, rainfall exceeds evapotranspiration for only 2 to 4.5 months and 4.5 to 7 months in wet semi-arid regions. Dryland regions produce more than 50% of groundnut, 80% of pearl millet, and 93% of pulses. Just a second. So, a large share of world's food grains comes from dry land. Rain-fed farming systems cover about 80% of the world's agricultural land and contribute to more than two-thirds of global food production. Rain-fed farming by region. Sub-Saharan Africa, more than 95% is rain-fed. That means it is directly dependent upon the rains for growing their food, etc. Latin America 90%, South Asia 60%, East Asia 65%, West Asia, North Africa 75%. Okay, dryland farming under pressure because of poor. This causes severe environmental degradation. Poor, okay. This results in long-term poverty in dryland areas. Definitely. This finally leads to low GDP growth, low per capita income, low expenditure, and low food and nutrition availability. Okay. National status. India has a total land of 329 million hectares and an annual rainfall of about 1120 millimeters. Out of this, 224 million hectares are moderate to extreme drylands. These areas support about 40% of India's human population. These areas are mostly monocropped and depend only on rainfall. True, for example, sugarcane. Instead of high value crops, they mainly produce coarse 90% of coarse cereals, 95% of pulses, 75% of oilseeds, 70% of cotton, but productivity is low. About 90% of people in dry areas depend only on agriculture. It is true if you see in the rural areas as well, where there is less urbanization and low penetration of technology and facilities, you will see that even today most of the Indian families still practice agriculture as their main primary source of income. And when there are irregular rainfalls due to various factors such as climate change, the productivity of the crop would be very low, and farmers' income will also decrease quite significantly, and they will have to borrow more money from various sources, and they would eventually be thrown into below poverty line. Dry areas contribute about 42% of the total food grains in India. Out of 329 million hectares, about 175 million hectares, okay, about 50%, okay, about 30 million, okay, about drunk, okay. This is all raw data. I don't think so NABARD is going to ask us this data in prelims. Sorry, phase 1. I always get confused between phase 1 and the word prelims because I had been preparing for UPSC for past 3 to 4 years now. But the current availability is only okay. So let us see significance. In India, 128 districts are recognized as dry farming, out of which mainly central Rajasthan, Saurashtra region. The major crops of dry lands are, this is something to highlight: millets, sorghum, pearl millet, finger millet, oil seeds, mustard, rapeseed, ground seed, pulses, pigeon pea, gram lentil. Dryland agriculture contributes 80% of maize, jawar 90%. Okay, fine. Scope. Dryland agriculture has a very large scope because it is 40%. So they are just, again, they are giving us the data and trying to explain how important the dryland farming is, considering the semi-arid and arid regions in India or anywhere in the world. So they are just giving us arguments. We don't need to rote learn these arguments, like what is the status about how much percent of oil seeds are produced, etc. This data is subjective, and this is also subjective. Significance is also subjective. This is very helpful in your phase 2, not phase 1. Phase 2. This is also, scope is also for phase 2, not phase 1. So we can skip this. We first understood what is dryland farming, what is and why it is being used or why it is being practiced, and I think that is enough. If there is any major scheme or if there is any major fact to remember, then we can remember in the coming few pages. Major constraints for crop production in dryland agriculture. Let us see what are the constraints. Climatic constraints, rainfall variability, high temperature, dry winds, and high evaporation. Obviously, if you see today, due to climate change, there is increased number of highest number of temperatures, there is less amount of rainfall. That is why we are not able to utilize maximum output of our soil and our fertility of the soil and crops. So soil related, poor moisture retention, low fertility and soil erosion. Yes. Management, poor crop planning, low input use, lack of water harvesting. Yes. From management, we mean that some farmers are not able to properly manage the problems that are occurring in the farm. For example, a pest infection comes and infests your main crop, then a proper timely redressal mechanism is needed in that circumstances. Socioeconomic poverty, lack of credit. Okay, fine. Then we have, okay, they are explaining this agro, they are explaining this here. Climatic constraints. Okay. Variable rainfall we have seen, high intensity, uneven distribution. More than 50%, here we have a data, more than 50% of total rains fall within just 3 to 5 days, causing soil erosion. It is true if you see even today that they were saying that this is going to be the super El Nino year, the 2026 one. So what happened was the onset of monsoon came in the month of June, and it just rained heavily for the 3 to 4 days for a maximum period, and you see the news that major cities like Mumbai, Bangalore were flooded, etc. So that is causing very harmful effect for crop productivity, because what happens is your crops get completely drenched into the floods of water, and that is why it spoils completely your crops. There is lot of soil erosion taking place because of it also. So uneven intensity, uneven distribution of rainfall, late onset of monsoon. As I have said earlier, monsoon used to be very much predictable in nature, but due to various climatic phenomena like El Nino, La Nina, and so these climatic phenomena, what they do is they try to delay the monsoon and they try to mitigate the intensity of monsoon as far as possible. Then we have early withdrawal of monsoon. Yes. Prolonged dry spells. Yes. High temperature. Temperatures above 40 degree are common in dryland areas. So what will you do? How will you cultivate crops if crops are not able to withstand temperature exceeding 35 degrees? You can't put ice into the crops. So how will you do that? That is a major constraint. Low relative humidity, high evaporation and evapotranspiration. Potential evapotranspiration exceeds rainfall during most of the year in the drylands. Okay. And then we have hot dry winds. Lu is an example. Lu is one of the hot dry winds, and it is primarily because of western disturbances. Okay. Then we have soil related constraints. The major soil types in dry land areas are alphy salts, vertisalts, and antisalts. Let us see what are these. Alphy soils are about 30% of dryland area. Red soils of peninsular India. Vertisoils are black soils with vertic property. Antisoils are alluvial soils, and that is only 10%. Okay. Inadequate soil moisture, shallow wind and water erosion, soil surface crusting after rain, compaction and hard pan formation, poor organic matter content. Okay, let us just, what we'll do is we will try to get an overview idea, because I don't see a much greater cause in explaining the detailed functions of each topic. Okay, So I will just have a quick overview. Dry land soils are described as not only thirsty but also hungry. They suffer from moisture as well as nutrient stress. Nitrogen uniformly prevalent in all dry land soils. Phosphorus, red and laterite soils. Potassium, red and loamy soils. Zinc and manganese, specific crops like groundnut and sorghum. Iron, calcareous soils, and organic matter very low almost everywhere. Okay. Reasons for poor fertility. What are the reasons? Low water supply, high temperature, low moisture, rapid decomposition, and less crop residue addition. Erosion removes nutrient rich topsoil. Fertilizer use is almost nil or very limited. Salinity develops because of excess rainfall is limited, and poor moisture reduces nutrient movement and fixes phosphorus into unavailable forms. Okay, fine. Then we have soil erosion and degradation. Out of 329 million hectares, about 75 million hectares are degraded. 50% of the cultivable land suffers from soil erosion and salinity. This is important. Let me highlight this. This is a very important fact. About 30 million hectares of fragile land are still progressively degrading, both water erosion and wind erosion. Okay. Then we have management constraints, lack of inadequate, lack of plant protection. That is the same thing that I just explained here. What they have done is they have tried to elongate the PDF as long as possible. They are forced to add more content as a coaching institute. It is fine. Socioeconomic constraints we have already covered. I have explained it here. You can see here I had explained, and that explanation is quite sufficient. You don't need to master this, because I have seen the PYQs, and in PYQs they are asking us the facts and the concepts in very detail. They are not asking you cause and effect questions. Okay. Drought generally means a shortage of water in a region, affecting drinking water, agriculture, industry, rivers, and human use. Aridity is a permanent climatic condition, but drought is a temporary condition caused by low rainfall for a short period. Definition of drought. There is no single definition. Early workers defined without rainfall according to Ramdas, IMD. Okay. Irrigation Commission of India defined drought as a situation where annual rainfall is less than 75% of normal rainfall. Classification of drought. Let us see. Permanent drought, found in desert climates. Agriculture is possible only with irrigation. Seasonal drought, found where there are distinct wet and dry. Okay, I understood this. Season, that means in summer season there are situations like drought in most of the cases. Contingent drought, caused by abnormal rainfall failure, usually brief and local. Okay. Then we have invisible drought, occurs even with rainfall when water is still not enough to meet crop evapotranspiration demand, so yield remains below optimum. That means rainfall is occurring about 250 millimeters, then too this drought can occur. Like this amount of rainfall is not sufficient for Kharif season. Okay. Based on users affected, meteorological drought, rainfall remains below normal for a long period. IMD defines it as rainfall less than 75% of normal southwest. Okay, severity, moderate means 20 to 50, severe means more than 50% efficiency. Atmospheric drought, caused by low humidity and often hot dry winds. Plants usually recover later. This is called a midday wilt. Hydrological drought happens when prolonged meteorological drought reduces surface waters from dams, reservoirs, and tanks. It creates water shortages for all water users. Okay, agricultural drought occurs when soil moisture is not enough to match crop water need. It develops gradually and is also called soil drought. It is caused by scanty rainfall and uneven rainfall in time and space. It usually means a dry period during a crop growth that reduces crop yield. Main causes: inadequate rainfall, uneven rainfall, long dry spells, late onset of monsoon, early monsoon withdrawal, poor soil and crop management. In India, 68% of the country is drought prone in different degrees. About, okay, that is just they are just dropping the data here and there. About 33% area receives less than 70, okay. Based on time of occurrence, early season drought due to delayed monsoons, mid season due to long gap between rains and inefficient, and late season, that means due to early cessation of rainfall during maturity stage, okay. Based on intensity, drought intensity can be judged by the ratio of actual evapotranspiration to potential evapotranspiration during crop growth. So during this is severe, moderate, mild, low and nil. One means it is perfectly balanced. Based on periodicity, IMD studied from 1871 to 1967 using rainfall data across from 306 stations. Severe drought years were observed in these years, and even when more than 40% of India was affected. Consecutive drought years also occurred, such as 14, 15, 16. Drought years were also recorded in these many years. Recurrence pattern in India: Assam and hilly regions drought is very rare. Madhya Pradesh, coastal Andhra Pradesh, southern in western Rajasthan once in 2.5 years. Offer terms of drought. Other terms of drought: apparent drought. What is drought for one crop may not be drought for another crop. Physiological drought: water is present in soil but plants cannot absorb it due to high salt concentration, as in saline or alkaline soils. Socio-economic drought: crop failures causes food shortages. Famine drought: a severe condition where food access collapses on a large scale. Ecological drought: ecosystem productivity falls greatly because of environmental stress and degradation. Okay. Effects of drought on crop production. Water relations, photosynthesis, hormones, nutrition, growth and development. Let us have a quick read. Water relations: water absorption, movement and transpiration are disturbed. Plants lose turgor because absorption is slower than transpiration. Photosynthesis: reduced because of lower photosynthetic rates. Hormones: growth hormones like cytokinin, gibberellic acid and IAA decrease, while stress hormones like ABA, ethylene and betaine increases. This names of hormones are important because it is the first time that I am hearing it. Nutrition: nitrogen fixation, uptake, assimilation are reduced. Overall NPK uptake also decreases. Growth and development: leaf, stems, fruit decreases. Okay. Reproduction and grain growth: drought at flowering and grain development reduces number of fruits and grain weight, and it can dry pollen and reduce its yield. Okay. Yield loss depends on how much of the dry matter is the economic product. Okay. Contingency planning means changing crop and field management practices to reduce damage from abnormal rainfall. It is just to mitigate your crop management in the regions or in the time frame where there is a drought occurring. When these correlations are done after crop establishment and during crop growth, they are called mid-season corrections or mid-term corrections. Contingent crop plan: a contingent crop plan means changing the usual crop when normal sowing is not possible because of bad weather. This plan is highly location specific. The chosen plan should match the length of growing season. Proper planting geometry: plant population is often reduced to 33 to 50%. By 33 to 50% depending on rainfall. If sowing is delayed, fertilizer response becomes low, so fertilizer dose should also be reduced. Repeated intercultivation helps prevent loss of soil moisture. rainfall abnormality and crop effect, delay in onset of monsoon, delay in onset of rainfall. Sowing is delayed, cropping season becomes shorter, early withdrawal of rainfall, moisture stress at maturity, grain filling is affected, dry spell immediately after sowing, germination is poor, and crop population also decreases. Dry spell during vegetative stage, stem elongation, leaf expansion, branching, all are affected. Dry spells at flowering, anthesis and pollination are affected. Grain pod number decreases. Dry spell at ripening, grain filling and grain size are also reduces. Then we have mid-season correction. Correction is a management when unexpected weather problem occurs, such as early monsoon withdrawal. The drought period may last from 3 to 6 weeks. Main mid-season correction measures. Okay, so this is the main plan, I guess. Thin crop stand, especially more sensitive crop in an intercrop system, such as sorghum or red gram. If enough rain comes after severe dry spells and the season is still long enough, ratooning of sorghum and bajra is useful. Okay. Spray cycocel in barley and wheat to reduce top growth. Nipping in chickpea helps reduce excess vegetative growth. Population can be reduced by removing every third row, every third plant, depending upon soil moisture. The population may be reduced from 25 or 50% of the normal level during dry spells. Management by rainfall productivity. Delay in monsoon, delay in okay, fine. Dry spell immediately. So what are they going to do? Mulching, KCI spray thinning 30%. Dry spell during flowering, anti-transparents, fodder harvest, ratooning in millets. Dry spells during ripening. Okay. So this was about the contingent plan. Now we have crop management practices. Okay. Late onset of monsoon. If the monsoon starts late, normally grown crops cannot be sown in time. This can reduce the yield. Transplanting. Useful under delayed sowing. Transplanted pearl millet often gives higher grain yield than direct seeding. In finger millet, 20 to 25 days old seedlings of medium duration varieties are suitable. Alternate crops or varieties. Use crops with shorter duration or better late sowing performance. For example, in Telangana red soils, Kasturvar Aruna performs better than pigeon pea under late sowing. Dry spell immediately after sowing may cause poor germination, soil crusting. If plant stands below 80%, it is better to resow than continue with a poor stand. Break in monsoon or mid-late season drought. If drought occurs 40 to 50 days after sowing, leaf area is maximum and soil moisture gets used up quickly. In such cases, reduce leaf area by thinning. Ratooning of drought affected sorghum can help after rain. In indeterminate crops like castor and pigeon pea, if plants recover after rain, spray 2% urea after wetting up the foliage. Weed control and dust mulching are useful. Life-saving irrigation can reduce stress. If water harvesting is available, use recycled water. Opening dead furrows at intervals helps conserve water. If the dry spell is short, mulching helps extend soil moisture availability. Intercropping reduces risk and spread drought impact. Permanent drought. Okay. Permanent drought is common in arid regions. In such areas, rainfall exceeds evapotranspiration for only about 4 weeks or less. So, even drought-tolerant crops can face moisture stress. Therefore, alternate land use systems are needed for stable production and income. Okay. In the black soils of the Deccan Plateau, farmers usually sow rabi crops like sorghum, safflower, and chickpea after monsoon ends in October. These soils crack by mid-December, which reduces the yield. Early sowing of rabi crops improves yield. In black soils of Maharashtra and Karnataka, chickpea and safflower give better returns than wheat under conserved moisture. In Belarus black soils, Rabi sorghum performs better than cotton. Other drought management practices: seed hardening, soaking seed in solution and drying them before sowing them to improve drought tolerance in seedlings. Okay. Pre-monsoon sowing, sowing 2 to 3 weeks before monsoon in dry soil so seed germinates after first good rain. Anti-transparent substances applied to reduce water loss. Mulching, covering soil with material to reduce evaporation and conserve moisture. Okay. Okay, so now next we have is alternate land use. Let us see. In many dryland areas, annual crop farming is not profitable because of uncertain rainfall, poor soil and poor management. In some places and farmers have stopped cropping and left land fallow, which later becomes wasteland with unwanted vegetation. To stop this, alternate land use systems like grasslands, agroforestry and horticulture are recommended. Main reasons: annual crop production is often uneconomical, crop yield is low, continued annual cropping, okay. Grasslands and tree-based systems are less risky, more productive and more profitable. Land capacity and suitable land use. The choice of alternate land use depend upon land capability class. Land capability class recommended alternate land use. Class 2 means dry horticulture. Class 3 and 4 agroforestry, lay farming. Class 5 pastures, silvipasture, tree farming. Class 6 rangelands and woodlots. Class 2 dryland horticulture. Fruit trees that can tolerate drought can replace annual crops in drylands. Criteria for selecting fruit trees: drought tolerance, suitability to different soil types, flowering and fruiting during periods of available moisture, quick recovery after pruning, fast recovery after stress removal. Fruit trees by rainfall: 760 to 700 millimeters. Bear, pomegranate, cashew, sapota, jamun, amla. 900. So excess rainfall will give you mango, cashew, custard apple, guava and fig. Fruit trees by soil type: black soil, red soil. Bear, sapota, pomegranate. Okay, so I think they have just copied it to here. Systems of dryland horticulture: pure horticulture, fruit trees only such as mango and cashew. Agri horticulture: annual crops between fruit trees such as mango plus groundnut plus bear or plus cowpea. Hortipasture: fruit trees combined with grasses and legumes such as bear or guava. What is this? Centrus and Stylosanthes. Okay. Pastures and grasslands. Forage crops. Forage crops are very important in dryland farming because they support livestock production and help stabilize farm income. They are also useful on marginal sloping eroded and degraded farms of soil conservation and wasteland reclamation. Then we move to forage crops for drylands. Annual cereals: sorghum, maize, pearl millet. Annual legumes: cowpea, cluster beans, etc. Then we have perennial grasses: Centrus ciliaris, Centrus citigraris, Centrus okay, okay. Annual grasses, this perennial legumes. Okay, this is scientific names. Ways to include forage crops in drylands. Grasslands or pastures. Perennial grasses and legumes are used for grazing. Cut and carry feeding hay or silage. Strip cropping: alternate strip of grasses, legumes and annual crops are grown. Lay farming: perennial forage crops are grown in rotation with annual crops in 4 to 5 year cycle. For example, Stylosanthes hamata 3 years, sorghum 1 year and castor 1 year. Advantages of lay farming: provides fodder to cattle, Low risk system, conservation of soil and moisture, improve soil salinity, soil fertility, prevent soil compaction, helps control perennial weeds. Tree-based systems, silviculture means growing trees. When trees are grown with field crops, it is called agri-silviculture or agroforestry. Trees are useful because they provide fruit, fuel, fodder, timber, wax, resin. They also help in soil, nutrient recycling, and environmental protection. Main tree-based dryland system. They are getting too much into, I guess, the topic. Let me see. Okay. Agri-silviculture, trees with annual crops are grown together in the same field. Trees and annual crops are grown together in the same field. Trees are planted about 5 to 8 meter spacing, and crops are grown in the interspaces during the rainy season. Then this is one of the example. Then we have silvipasture. Leguminous fodders are grown with grasses and legumes. Alley cropping or hedgerow intercropping. Annual crops are grown in the spaces between tree or shrub hedges. The hedges are cut back to 0.5 to 1 meter at sowing time and kept pruned during crop growth to reduce shade and competition. Examples: Leucina desmanthus hedges with sorghum, maize, pigeon pea or sunflower. Benefits of alley cropping: gives green fodder from hedgerows in the dry season and food or fodder from annual crops. Uses off-season rainfall through trees or shrubs. Hedges reduce rainfall and soil erosion, especially on slopes. Pruning can be used as fodder, fuel wood or mulch. Then we have timber fiber system. This system grows trees with perennial fiber crops. And this is the example. Choosing trees for dryland. Trees for dryland should have these qualities: multi-purpose use such as fodder, fuel, timber, and wood, ability to grow in different soils and climatic fast growth, ability to tolerate heavy pruning. Suitable trees by soil and rainfall: black soil, eucalyptus, okay, red soil. These are all scientific names. Important institutes related to dryland agriculture: CRIDA, Central Research Institute for Dryland Agriculture, Nodal ICR Institute for Dryland Agriculture. It develops climate resilient, rain-fed, and location-specific technologies for soil, water, crop, and farm management. CAZRI, Central Arid Zone Research Institute. Okay, NRA, NISM. Let us see if there is a recent institute in all of this. No. Center of Excellence on Dryland Farming, collaborative global platform for dryland research. It promotes cooperation among institutions for better technologies and solutions for dry regions. Okay, so I don't think so it is feasible to learn everything in this. I mean to learn every institute. So it is fine just to do this because it is a nodal ICR initiative and this one. And I think that would be sufficient for this. So yeah, we have seen many topics. Let us have a quick overview of this so that we don't forget what we had read previously, because it has been around 40 minutes that we are into this video and we tend to forget the things that we had revised earlier. So let us have a brief overview, a quick revision before ending the video. Dry farming, then dryland farming, rainfed, we saw the difference. Then we saw, what did we see? We saw definitions. We saw definitions of drought, dryland. We saw characteristics of dryland. Then we saw global status of dryland agriculture and national status. We saw national status. Then we saw significance of dryland farming, scope of dryland farming. We tried to understand that. Then we saw this one, major constraints of crop production in dry land agriculture. Climatic constraints leads to what? Soil related constraints, management constraints leads to these problems, socio-economic constraints leads to these problems. And then they had just explained this in very detailed format. Soil, then management, and then socio-economic. Then we came to the topic of drought. Then we saw the definition of drought. That means drought is a situation where annual rainfall is less than 75% of a normal rainfall. Then we saw different classification of drought, types of drought based on duration. Then we saw based on uses affected. Then we saw based on time of occurrence. Then we saw based on intensity. Then we saw based on periodicity. Then we saw based on other terms. Okay, we saw other terms for drought. Then we saw effect of drought on crop production. So these are the topics, like how hormones are affected, how nutrition is affected, how photosynthesis is affected because of drought, how reproduction, how yield is affected. Then we saw contingency planning for drought, like mulching. We are doing mulching. Then we are doing different kinds of things for mitigating drought effects. We are doing mid season corrections. Then crop management practices, and the crop management practices bit was a little bit more longer as compared to other. Then we had alternate land use. Alternate land use, we saw main reasons, land capability and soil and suitable land use. In this classification, class 2, class 3, class 5, class 6. Then ways to forage and main trees based dry land. We saw these. This was an important heading. I think they should have highlighted this more. Main tree based dry land systems. And this we saw agri-silviculture, silvipasture, alley cropping, and timber fiber system. So, and that was it. Important institutes related to dry land agriculture, and I think that was the whole summary of the point. And so yeah, that was it for this video, and I hope to see you in the next one. Thank you.